Good afternoon, everyone. My name is Astelia Salam. I'm going to present to you part of my ongoing work. Estimation of groundwater hydraulic characteristics in the Lower Olenfis River Basin, Namibia. I did this work under supervision of Dr. Mtoko and Dr. Mshingami. This is the outline. The Kalas region being the region under which my study area is located is one of the driest regions in Namibia. And groundwater occurs under sedimentary and fractured crystalline basement aquifers. And over the past years, there have been a number of recorded dry boreholes being drilled due to acidic nature of the area. And then this has necessitated the use of advanced geophysical techniques to increase the success rate of the borehole to be drilled. And according to Rohe and others, exploration in these areas to increase the success rate, it should focus on the faults, fractures, and joints of the weathered rocks of these crystalline and sedimentary rocks. And also, as it was mentioned earlier, we need data in order to able to monitor our groundwater. And there is, according to Bock and Todd, there is a need to increase the network of our monitoring boreholes in order to be able to monitor this groundwater in the area. And then this also forms the baselines of this study to improve the aquifer parameters of this aquifer system within the area. The study area, as we can see, it is up is where the higher land, where most of the recharge comes from, towards the south, and it is annual rainfall is between 50 and 200, and it also one of the area with a higher mean annual potential evaporation. The geology, consists of the crystalline basement, as it can be seen down. And the sedimentary, the pink, and then also the dorite dikes that intrudes the Karoo. And then we can see that on the picture on the left, it just shows the evolution of the geology of Namibia, whereby our Nama is formed as a result of a collision between Congo and Kalahari. And on the hydrogeology of the study area, 3 main aquifer systems can be seen: the crystalline basement, sedimentary, and the porous one. And then on the picture on the right is an example from a typical Nama, whereby the red one is a contact between the sandstone and the shale, and it shows the contact acts as a conduit through which the fluid pass through that acts as a main aquifer for this area. And this is the method which was employed under this study. First was the data acquisition, whereby the hydrological data, geological data, allomagnetic data, and the ground magnetologic data, and the drilling and pumping tests were collected. And then the allomagnetic data were processed using the GeoSoft field. Several filters were applied to enhance the structures to be able to highlight the area of groundwater potential zones. And then the allomagnetic data were then validated with the magnetologic survey in the field, and then also the geological mapping in order to determine the suitable drilling site. After the selection of the drilling site, the drilling then occurred, whereby the air percussion was used, and then the geological logging was performed on the site. After the drilling, the pumping test was soon performed, whereby the constant test was done for 6 minutes, and then the data analysis was carried out using the FC methods to estimate the parameters. The FC method was used to analyze the constant test data, and on the picture on our right just shows the basic principle for this method used. And then this method depends highly on the available drawdown, whereby the geological mean was used to determine the available drawdown. And this is the coupling of the geophysics and the lithological logs, whereby the geophysics was correlated with the logs. And then the blue dotted line shows the water strikes. And the first image is from the typical crystalline basement aquifer, whereby the 3 are from the sedimentary. And these are the diagnostic plots as obtained from the FC method. They were all show similar trends, and then it resembles the one of a typical pumped from the single vertical fracture based on Klusman and Rada. And this is the summary of the pumping test analysis, the estimation of the sustainable yield, and late transmissivity. We used the basic FC because there was no monitoring borehole close to the pumping wells. And we used the basic FC and the Cooper-Jacob from the FC program. From the result, we can see the crystalline, being example, the gaseous one is from crystalline, has low sustainable yield compared to the others. And then this is also same as the Cooper and Jacob, also show low in crystalline. And for the discussion, the geophysics were able to delineate the area with groundwater potential, and then our aquifer system comprises of sandstone, as it confirmed from the litholog, and then sustainable yield from both the FC and Cooper-Jacob gives the similar trend. And also, what is noted is that the high sustainable yield and transmissivity were seen in sedimentary aquifers, and then this could be due to the several water strikes that were struck during the drilling. And then also This sustainable yield data compared with the literature value is much lower than the one in the literature. This could be to the fact that the AG used in available drawdown used in this study is estimated using the geological mean, and then also that the aquifer is not fully penetrated, and this could lead to the vertical flow and head loss. In conclusion, in the integration of geophysics, geology, hydrogeology, we're able to enhance the area of groundwater potential and increases the success rate because we're able to drill 4 successful boreholes out of 5. And main 2 aquifer within the crystalline and sedimentary aquifer were able to be identified with rock types such as gneiss and basalt in crystalline and sandstone shales in sedimentary. And Nama and Kalu sedimentary rocks were having a relatively higher sustainable yield compared to the crystalline basement. And because one of the points worth noting is that during the pumping test, one site has a higher, one site is so having a higher yield that when we were doing the pumping test, there were no drawdown because the pump we were having is small, and then we were planning to carry out pumping test at this site by getting another bigger pump. And then overall, the basic FC has demonstrated its value as a practical tool for estimating sustainable yield for this sedimentary and crystalline aquifer system, and then this will guide in groundwater development and monitoring in these arid regions. With this, I came at the end of my presentation. I thank you. These are the sources of information that I used for this study.
All right. Questions or comments? Any hands, colleagues? One hand, another hand, anywhere? Okay, can come through.
So my question relates to the duration of a constant discharge test. You've done it for 6 hours. Do you think that is long enough? Aren't you afraid of hitting boundary conditions, maybe at a later stage, if your pumping test is not long enough? Thank you. Yeah, no, the question just relates to the duration of the pumping test. You did it for 6 hours. Which 6 hours is normally considered a very short period. So I'm just scared when you're focusing on sustainability that you haven't reached any boundary conditions which may affect the sustainability of the borehole. So maybe it's just something to consider when you're doing your analysis of the pumping test data, and also to consider other fractured rock methodologies and what type of aquifer it is. So it's a comment. Let's leave it at a comment. Thank you.
Hi, yeah, I actually just want to add what Kevin said. So in other words, in your diagnostic plots, you can see the flattening, but also on the derivative, you can actually see fractures. So, yeah, just to add on to Kevin, well presented.
Okay, I think you are free. I don't see any other hand. I can free. No, you can. Any other hand? Oh, Prof. Just wait, there is a rooming mic coming.
Okay, thank you for your presentation. Yeah, it's interesting. I wanted to ask, just to be sure, the flooding that you see on your drawdown, on your semi-log plot, is it a result of because you are getting close to the, I assume, fractures, or yeah, that's the question I want to ask. Then, just to help you to respond to the 6 hours, I think the longer the better, but we can only, obviously, if we think about 24 hours, good, but if we think about a month, probably better. So yeah, I understand that, but I think if you also consider the application of the FC method, it does consider the possibility that, well, during your pumping test, you actually don't encounter the boundaries, but in future, if you do, then it does factor into that. That's why your constant rate pumping test is very high, but your sustainable yield is quite low. It does, I think, factor that, but maybe it would have helped. But let's say you do 24 hours, maybe you don't see the boundaries also. So yeah, just to comment on that, thank you.
Okay, thank you for the comments. I will take note of them and try to apply. Because this project is ongoing, we can take them in consideration. Thank you.